questions or those queries in today's session. So let me share my screen. Is my screen visible?
Yes, your screen is visible.
Right, yeah. So see, mainly the questions which comes into the mind when we start chaos engineering for many, okay, like I will say majority is like what is chaos engineering, right? So this question really comes into picture, and why do we really need chaos engineering like when we already have so many traditional testing practices? If I just keep calling out, there are many, right? So why we need one more, and why suddenly the chaos engineering is coming into picture, right? Am I audible? Is my network connectivity okay? Is anyone feeling any jitter?
It's audible.
It's audible, right? Like no issues in my voice. Just want to
Yeah,
verify.
no
No
issues.
issues.
No issues.
Okay, okay, thank you. Right. So, yeah, coming back to like this question comes to everyone's mind, like what is chaos engineering? Like why do we need one more test? And why suddenly this sudden like everywhere you're hearing this word chaos engineering? Why suddenly? Right. So those questions will be answered. So basically, if to give you in a nutshell, like why this chaos engineering is becoming very popular. To like I give this example every time. All right, like let's say you are building a bridge, and you have built a bridge, very strong bridge, and you have used all the traditional designing practices and even testing practices, right? So, but you never like you have designed it and all the formulas and everything has said that okay, your bridge is designed like your earthquake proof, but unless an earthquake doesn't come, or let's say even a minute earthquake doesn't come, we don't know whether this theoretically it is fine, right? It's working everywhere, everything is okay, but experimentally is it earthquake proof or not, right? That question comes into our mind. Now the same thing happens in a software world also, right? Like we are creating things, we are on cloud, we are implementing new technologies, and also we are implementing such technologies which are not with nowadays. The things have become so fast that we are adopting it in just 6 months, 7 months, any new technology. Even the community is not become so big, or even we haven't got much time to test it. Such technologies are getting into mainstream applications, right? So what is the surety that those applications or those new technologies which we are implementing into our applications are not will my application be able to withstand any failure which is unknown, right? So similar case happens on the bridge side. Let's go back to the bridge. Here what we do, so what's the what is the solution to this? Like how will I understand whether my bridge will be able to take some earthquake, or like a small earthquake it will be able to withstand, like, or I will not use the word withstand, or how it can take an earthquake. So what I will do is I will simulate an earthquake, right? And what I will do is I will simulate a small earthquake, not a big one but a small one. And if I observe some cracks in the bridge, then I know there is some problem in the bridge, okay, that I need to patch up. Or I will say like when a big earthquake will come, these cracks will be big holes. Okay, so that's how the chaos engineering also works, right? What we do here is mainly we inject failures purposefully, right? Like we know that which are small failures, to uncover some potential issues which will be there in the system, right? And mainly if you speak about chaos engineering, now there are a lot of different practices, like you have disaster recovery test, then you have failover testing, you have different testings which are available, which you can easily confuse with chaos engineering. But once you begin with this course, once you start understanding what we really do in chaos engineering, with two words which I call out, okay, you can clearly differentiate those chaos engineering from those different practices or different testings domains, and you will clearly understand why we need chaos engineering. Okay, so that's pretty much in the fundamental way why we need chaos. Now, what is the reason for the growth of chaos, right? That question will come into mind, like why suddenly this chaos engineering is growing. So there are multiple boost factors to that. Mainly cloud is one out of that. Then we have the growth of distributed systems, hybrid, or I will say some hybrid systems. Um, so grow the cloud, distributed systems, hybrid systems, Kubernetes based systems, all this complexity, right? Though these systems are making the life of developers simple by making the development cycle faster, okay, but at the same time it is making the testing of an application very complex, because if you see the applications which are hybrid or distributed, they will, like, initially, let's say there were applications which were maximum built on two languages, okay, like let's say Go and Python, let's, or some like something like that. But nowadays in a single applications you can find uh, the range of microservices, like let's say 10 microservices are there in an application, and each of those microservices can use different languages. So that complex the things are, not only the languages, even the DB, like, so one will be using MySQL DB, one will be using DynamoDB, some microservices will be integrated using Spring Boot, some will be, so that way the complexity is increasing day by day. And obviously the development has become faster, okay, we will discuss all this, why the distributed systems have given a push to the development cycle and why it has become faster and all, in upcoming sessions. But development has become faster, but the problem is the testing has become complex. So these integration points, or we can say, when these products are integrated with each other, there are a lot of potential issues which are coming in. And that's why like it was Netflix, the first company to find out that they need one more practice, or we can say the traditional practices are not enough. They need one more, like which can uncover those type of issues, which are specifically focused on these new generation technologies, right? And chaos engineering is that field. Initially, it was called mainly reliability testing and all, but nowadays it's very matured and everywhere it's called chaos engineering. Okay. Yeah. Coming to now, yeah, so that's the reason why we are seeing this sudden boost, and all these things we will learn in very in depth and in very detail as we go into the sessions. But just I wanted to give you an overview, right? Now, so what all will be covered in this course, right? So initially, so starting from, if I divide my course into some modules, starting from planning to I can say, I can't say script development, but I will say test development, to execution, to analysis, to automation. Okay, so I can divide it into this five parts. Okay, so planning is there, test development is there, execution is there, analysis is there, and automation is there. So in planning stage, we will mainly see how we can plan our chaos experiments. How do you develop your test plan? How you read your NFR documents? How you create, how you analyze your application and come up with different functional requirements, okay, non-functional requirements, those things and all we will see in the planning stage. In the test development stage, we will mainly focus on in two tools in this course. One is chaos mesh, and when we see chaos mesh, we will also see litmus in very briefly, because both are like brothers, okay, like if you know one, the other will complement very much. Okay, so litmus and chaos mesh, and the other tool we will see extensively is Gremlin. Okay, sorry, it's due to some connection issues. Yeah, right. So we will see Gremlin, and when we are seeing this, I hope my voice is not breaking, right? Please interrupt me if I'm not audible anytime. I'm audible, right? Everyone?
You are audible, Vishnu. Perfect.
Yeah. Right. So, yeah, we will be covering, as I said, Chaos Mesh, Litmus, and Gremlin. So, when I say test development, that I don't. So, what we will be covering here is how you implement or how you implement Gremlin or Chaos Mesh into your application. So we will go in 4 stages, or I will say 3 stages, starting from host to Docker container to Kubernetes based systems, so that basically you get an understanding of overall any system. If you get, you'll be able to implement Gremlin and these tools onto that. Okay, so that we will see. Then we will go for execution stage, where we will understand different types of attacks, experiments, how you run different experiments based on different services, systems, right? So that will be in the execution stage, where we will try to understand concepts like game days and all, and different types of attacks. Like many know what, like we have an attack called black hole, but where do we use this black hole and what scenarios, right? So those things and all we will see, and how you run those attacks. We will see those things in the execution stage. In the analysis, mainly we will be focusing on the metrics, monitoring, and all. So here we will see like what are the metrics you need to look into, right? So when I speak in the as a chaos engineer, right, I have to quantify my findings, right? So for that I need some metrics to show my stakeholders. So that we will see in the analysis stage, like what all metrics I can look into, what all I need to report, what are the things, looking into that I can come into a conclusion that there are some chaos issues there, right? So those things will be the analysis. And the automation stage, we will try to see how we automate our chaos experiments, and mainly focusing on Gremlin there. Okay, so the tools in this whole flow we will be covering is mainly Gremlin Chaos Mesh is the chaos tool you have. In the analysis stage, we will be using Prometheus and Grafana. So you will get a good understanding of the Grafana, how we use it for monitoring and all. In the execution stage and test development stage, basically we will be going through different systems. We have a microservice based application, demo application. We'll be using that for our all our hands-on. So we will deploy everything. Whatever I do here, you will also be able to do in your local machine. So there is no problem that you need to like, and everything is on the local machine. So what we will do is we will be setting up even the Kubernetes cluster on your local machine, and even this demo application, the microservice based demo application also, we will be setting up in your machine. So you'll be able to do whatever I do here with in your machine itself. And obviously, when we do this, right, you will learn about Kubernetes, because chaos engineering is all about cloud and all. You need to understand majorly what is Kubernetes, because widely you will see this. Okay, so what are Kubernetes pods, containers, Dockers? What is Helm? Different things related to Kubernetes. How you debug Kubernetes mainly. Okay, so because when you are doing chaos engineering, you need to have an understanding of how you debug Kubernetes, so that in a very easy way, and how you can uncover potential issues, right? So those things we will see as we progress. And in automation, we will use Jenkins. So you will learn Jenkins a high level way. Then to call out, yeah. So those are the tools which we will cover, and things which will be covered in the course. Yeah, any questions, anyone till now? Yeah, anything related, like whatever would have come in your mind, anything.
Hi Vishnu, Pushpin here.
Yeah, yeah. Hi.
Uh, Hi. Actually, I put on the chat also. So my question will be on on-prem servers, because I don't want, or my company don't want to expose our
Hmm.
infrastructure to the cloud. And I understand
Yeah.
that Gremlin and other tools are means on the cloud side. So what is the workaround for that one?
Correct, correct. Yeah, so that's a very good question. Okay, so that's where the open source tools like Chaos Mesh and Litmus comes into picture. They are not on cloud. They are an open source tool and standalone tool. Okay, you have to install it. But again, Chaos Mesh works on Kubernetes, so you need to have a Kubernetes system. Otherwise, the other workaround with that is you will have to go with some other chaos tool like chaos toolkit, or chaos toolkit will be a good option, but which will be easy for you. Like once you learn the course, implementing chaos toolkit won't be a tough thing. Only thing, you will have to learn a little bit of Python for that. Yeah.
Okay, thanks.
Yeah. Pravesh,
So,
Vijay, any questions?
I
Yeah,
have
hi,
a
yeah.
yeah, I have a similar question, but just in case if you don't want to go with a licensed tool or an open source tool, can we develop an in-house tool? Like after completing this course, will you be in a position to develop an in-house tool?
Yeah, so that's a good question. So the thing is, you can, but that I will call as a very expert call, because there you will have to learn a good amount of coding, which I will not teach in the course. Coding, because this course has been developed in such a way that it's mainly for who are into testing and who are not into very much into development. So, but if you're good in development, and if you're good at some coding languages like Python, as I said, Chaos Toolkit, and there are some other tools which can form your framework. Okay, based on that framework you can build on. Otherwise, if you're building from scratch, I will say that will be like a very big task, and I don't think it will be worth the spending time, because the tool might be less cheaper compared to that. Okay, so yeah, you can, but that's the answer for it.
Okay, thank you.
Yeah,
Hi Vishnu, Trinad here.
I don't know. Yeah.
In this course, Grafana and some dashboards, is it covered with, like every configuration and everything?
I won't say, like, as I said, like, this is a chaos engineering course, so we are not going very deep into Grafana or Prometheus, but after like, we have the session completed, right? You will have a pretty much good understanding of what is Grafana and what are the metrics we are clearly looking into, like when we are performing some chaos engineering experiments, right? Where you need to look into how to create dashboards, those understanding you will get.
Okay.
So, like, what different types of chaos will be learning here? Like, for example, latency,
Hmm.
and then will it be, latency, introducing latency within the containers or
Yeah.
any other
Hmm.
uh, platforms?
Yeah, so latency is just one type of attack, and also, as I said, attacks the main. If you take chaos engineering, the main expertise is not in performing the attacks, but in choosing the attacks. Okay, like for example, when you are attacking a DB, or when you are attacking a queue service, so which attack to go with? Okay, or like what is the significance of each attack, and which, like for example, you cannot attack all attack. You cannot attack any application with any attack. Okay, so there has to be some motive or objective behind each attack. So in this course, mainly in Gremlin, we have around 12 attacks. So we'll be going through all those, like on different scenarios, like where are these attacks used for, and in hands-on also we will be seeing all those, like black hole, packet loss, latency, the CPU attack, memory attack, shutdown attack, and where these, like for example, I might not have all the scenarios with me to show you demo, like for example different DBs and all, but I can show like one example, and also call out my, even I have I have some cheat sheets which I have created for my purpose, which I will share with you all the documents, which will be helpful for you in your projects also. Just it's like which service to use, what and all, what attacks, something like that. Yeah, so that will help you out. Say,
Sure. Thanks.
yeah. Any other questions, Vijay, Shirabdi, Lazmi, Abhimanyu?
Vishnu Pravesh
Uh,
this side.
Yeah, Pravesh, go ahead.
Actually, I'd like to understand chaos engineering from two sides. Okay, first thing is, do we need to run this test in production as always?
Yeah, that's a good question. Next one.
Next one is, I'd like to understand the chaos engineering as a India job market prospect.
Yeah, okay. Right. So see, let's take the first question first. So chaos engineering now, like if you see it as like let's go back. So it, in the reliability testing, or whenever we say the SRE and all, the production comes into our mind. But chaos engineering is very mature now, and it's not just in production, or I will say majorly it's not in production. It's in the lower environments, right? So, for example, mainly the performance environment and the test environments are the two environments which are widely or majorly used for chaos engineering, and all your chaos engineering experiments are done on these lower environments first. And once your lower environment testing is complete, we have a process where we test those scenarios which we need to make sure that it won't repeat in production. Okay, only those scenarios we test in production, and the windows are also very low, like around 10 minutes, 15 minutes windows is generally what we get in production. And that also we will discuss all this, like how you implement and all. Generally, it is bi-weekly, like in 2 weeks or 3 weeks, you get a window and you test your experiments in production. So no worries, like if at all you're not testing in production also, chaos engineering is very much in the lower environments. Okay, so that's what we will be seeing also, like how you choose what environment for which scenarios. Because as I said, it's not like single environment also which you go ahead with. You have to use multiple environments based on what use case you are testing. Okay, but yeah, we do it on lower environments. That's the first question. Second one, if I'm correct, you are asking how is it relevant for Indian market? Is it, Pravesh?
Yes, yes, correct.
Right. So yeah, coming to Indian market. So recently, to call out, okay, just if down the line 1 year, if I see the implementations which were happening were very less, and also the budget allocation was also very stringent. Like everyone were looking into open source, right? But nowadays, from past 2 or 3 months timeline, I will say, the implementation has become drastic, because 10 out of like let's say 5 or 6 organization which I know have started implementing it, and also they have released budgets for paid tools like Gremlin. Okay, so and especially they are taking it very seriously, because they are setting up a separate team for chaos engineering, which never generally happens. Okay, and the reason behind that is two driving factors. One is the cost, because nowadays when we speak about cost cutting can also happen by reducing the cost or the expenses, right? Chaos engineering in turn also makes sure that your system downtime is very low, and also it tries to inculcate other features like optimization of your system and all inherently, though it's not our main objective, but we optimize the system very well. Okay, so that's one reason, mainly the cost. And the ROI of like what people are seeing now is the ROI of chaos engineering is very good. Okay, so yeah, so as I said, so Indian markets, it's really relevant, and nowadays we are seeing it also in action. And if I speak about the foreign market, obviously it is, because I can see now jobs which are chaos engineering related, which are paying very high, like around 3.5 lakh dollars. If I see the job market data, 3.5 lakh dollars is what they recently Tesla was looking for a chaos engineer role, right? So yeah, so in foreign also it is getting popular. So market wise, it is very huge now, and it might explode. I will not say it's exploding now, but it might explode in next 1 year. Explode is meant like you will see it in really in mainstream. Okay. Yeah.
Yeah, thanks for addressing my questions.
Yeah. Any other Pravesh? Any doubts?
Nothing, Vishnu. Thank you.
Yeah. Alekhya, any doubts? Any queries? Okay, yeah. So, so to now to cover the rest of the things, so now we know what generally we will be covering, and if the syllabus also will be in that way, it will be moving, and everything whatever we speak or whatever I speak will be done hands-on also, so which you will also be able to do. Uh, the other things to just call out, I have a organization license of Gremlin, which is a paid license. So I will be sharing those license with you all. So you will be able to access the enterprise version of Gremlin, which is not a free trial, which is a paid one. So, and I will keep the access for around 1 month or 40 days, and till the course is running. And you can also do some hands-on and all. Even you can use it for some POCs and all. Once you after 40 days, I will just because just to make sure that it's not crowded with so many people using the same account, right? So I might remove few, but later on also, if you need some access for some quick work or something small, I can re-give like I can give you the access again. You can use it. So that's one thing I want to call out. And we will complete the Gremlin certification also by end of the course. So you will have completed the enterprise certificate of Gremlin, which is a very good certification to showcase your chaos engineering talent. Okay, skill I will say. And yeah, and yeah, Prasad, you had some question.
Is there any way you can move 30 minutes before? I mean, it's instead of
Yeah, yeah. So thing is, 9 p.m. is what I got when I got request from many, so I kept 9. But yeah, based on the audience, how they how, like majority want, like if they
yeah,
want to shift the timing somewhere, we
yeah,
can plan.
8:30. 8:30. Is it possible? 8:30 to 9:30. I mean,
That's what. So which I cannot decide now. Based on
okay,
majority, I
okay,
can plan.
okay.
Yeah, because yeah, yeah. But for me, it's possible.
Yeah,
But let's see
sure.
how the majority. Yeah.
Yeah, Vishnu sir, this is my request as well. If you can move, means prepone this meeting or this session earlier,
Hmm.
like what Prashad
Okay,
has
okay. So
mentioned.
half an hour
Maybe we
earlier
can
is
just
good for.
maybe we can put a poll in the WhatsApp. So yeah.
Yeah, sure, sure, sure. Yeah, I will put it. What about others? Like, how many of you have like you want to shift it little early? Anyone else?
It's okay for me. 8:30 to 9:30. That would be okay for me.
Yeah, yeah. Okay. Yeah, yeah. That's fine. We can shift it to 8:30. Not a problem. Yeah, I can put it in the group also. Not an issue.
And
So
what
one
about the
question,
Right.
course duration?
Yes, yeah. Yeah. Go ahead.
Sorry.
one question is like we have a Kubernetes cluster. Uh,
Mhm.
so do we are we running this on Azure cloud or AWS cloud? So is there any specific to Kubernetes any examples we
Hmm.
are running here for chaos?
Yeah, so see, I give a brief overview of AWS cloud, and also I will try to give a small brief comparison of AWS and Google Cloud, so you will understand that pretty much all the clouds are similar, only the names are different. That is one thing. Second thing is whatever we do, no, we are doing it on the local machine. Okay, so you don't need any cloud account because why I did this is if you want to create a cloud account, a free trial account, and all, sometimes it's not possible for everyone, right? So sometimes even they get charged like who are new to cloud. So what I did is the whole course you can do it on a local machine. Only few part you need to do on cloud, on AWS cloud. Okay, only the parts like some latency attack and all where you need a static IP. So only that part we will do on AWS cloud, which you can also do, which I will be showing you clearly how you do it. Rest is on your local machine. Okay, so no worries. Any other questions, anyone? Yeah,
Yeah, sir.
yeah, Pushpa.
Yeah.
Yeah,
So Pushpin here. So my question will
yeah.
be like, what will be the course duration, and will it be from Monday to Friday or weekend as well?
Weekends there won't be any session because that's the only day I take a
That's
little
fine.
rest.
That's fine.
But yeah, it will be only on working days, Monday to Friday, and total course duration which we are planning is around 20 hours. So
Okay.
only thing is sometimes like daily it will be 1 hour only, but sometimes like let's say when I'm taking some sessions on Kubernetes, which I will inform prior, I might go somewhere 1.5 hour because those are some topics which need continuity. But otherwise, it will be we'll stick to 1 hour duration. And if someone wants to complete the course little early, like if majority want to do that, then we can plan some Saturday sessions also so that we can cover up little early. So overall 20 hours.
That's fine.
Yeah.
That's fine. And when you are planning to start, I mean,
So as
Monday
soon as
or
like today we have the demo,
okay,
right? Tomorrow
understood.
onwards, the day one will be. Yeah.
Okay, Thanks.
Yeah. Okay. So yeah. So let me so as I said, now we know the course curriculum, and you can also browse through the. If you have any doubts, you can always contact me back. We can go into this. So what I will do, I will be doing is I will be also giving you. Is my screen visible?
Yes, it is visible.
Yeah,
Uh,
just I closed
I
it
don't
once.
think so. I
Yeah,
think it's stopped.
yeah.
Yeah, it's
Now it will
visible.
be right.
Yeah.
So I'll also be sharing you a drive link, which will have all the materials which we will be covering in this course. Um, Let me show you that. And that link, like what I generally do is it's the Google Drive link, and I keep updating that link with different materials which I come across, which I create or which I make, even different scripts and all. If at all, if I write some scripts and all, like for example, we have a section where we speak about Jenkins, right? So there we are using a pipeline script, a small, and when I say script, no need to worry about like it will be a big coding. No, it will be very simple things only which we will be covering, and you will understand that it's not a very big rocket science behind all these like Kubernetes and all. You will very easily understand what these things are. And one, like I have seen this in different batches, different students, that when they complete this Kubernetes section, the cloud mainly, the Kubernetes, uh, like I get this excitement in them, or I can say the surprise that oh they like was Kubernetes so simple, right? So that type of understanding. So it will be very simple for you all. Yeah, so these things I will share with you all in different modules which I take. You can find all this in the drive link, different things. So everything I will share with you all, the materials whatever I cover. Okay. So yeah, so this will be shared once we start our real sessions. That is one thing which I wanted to cover. Yeah, yeah. So any questions?
Sir,
Otherwise,
can
let's.
I ask you like one question? Like, how much is the cost for the certification?
Which one? Gremlin. Gremlin
Yeah,
is what you are
Gremlin.
asking. Yeah, so Gremlin is totally free.
Yes.
Only thing is, yeah, it's a totally free certification. Okay, but only thing is, like, I will help you to clear it out because I think there is only two or three attempts which you can attempt. So with one, so yeah, so that we will get it cleared. Okay. So not a problem. And obviously, by the end of the course, when you reach that section, you won't need my help, frankly, because you will have all those what is required. You yourself will feel okay. It's very simple. You will once we reach the end of the sessions, all whatever is required for certification will be covered.
So it is free of cost, is it?
Yeah,
The
it's free. It's
certification
free.
is
But
free. Okay.
yeah, better to complete it as like for example, in next 6 months,
Yeah, yeah.
because I'm close to the Indian community, right? So it might get paid, okay? So
True, true.
because they
Agree.
are keep on changing things, yeah. So better to finish it early.
Okay, thanks.
Yeah, right. So let's then jump into any other questions, anyone, or else we can just. Okay, yeah. So let me share my screen. So now we have seen we are trying to understand why the chaos engineering suddenly grew, right? So in that the major factor which is contributing to this growth is the distributed systems, right? Now the demo application which I said we will be using is one microservice demo application, which is an e-commerce application, which is a basic e-commerce application for which like it's like a sock shop, like generally, the developers use this demo application for understanding microservices, containers, and all. So we'll be using the same demo application. It's on GitHub. It's an open source application. And if you see the design of that application, I hope my screen is visible. Yeah. Okay. So here, if you see the architecture, see, now if you see there are different microservices built on, like for example, if you see order, payment, user, catalog, we will discuss what are microservices soon. Okay, if someone is new to those, we will try to like you will easily understand what it is. Anyways, so this order, payment, users, all of these are microservices. And if you see the technology, different types of technology languages which are being used, like Go, one is MongoDB, one is MySQL, one is on Go programming, one is on Java. So and one is on Node.js front end. So the complexity of this application is increasing with different types of technologies being merged together into one application. Okay, so we will discuss this. For example, now let's try to understand. So let's go back down the line to, let's say, 10 years, okay, or like not even 10 years. Yeah, let's take 10 years, okay. So you had an application. Let's say you had an application. Now, see, now let's say you had an application, and I'm saying about like little time back, okay, and the developers are developing it. Like, let's say there are some four functionalities. I will not call services like purposefully. There is a reason. So I had an application, and in that, let's say there are four functions like ordering is there, accounts is there, okay. Then I have payments, okay. Then I have location, let's say. Okay, so now if I try to see this, these four functions, now let's say location is required by all these functions, okay, and pay order, or after order only I can develop payment, and accounts is required by payment and orders. Okay, so there is a interlink, or we can say, unless a developer doesn't develop location, order, accounts or payments guy people cannot start working on those. Okay, they had a dependency with each other. Okay, now this dependency which they had is of two things. One is the hardware, and one is of the software, or I can say the code. Okay, so now if I take these two things, now let's say I want to make this, I want to solve this problem. Okay, like this dependency with each other. Okay, so if I want to solve this problem, these two have to be solved, like these two things have to be made independent. Okay, so first, what happened with the years? Initially the code dependency was reduced. So how did they reduce the code dependency? By introducing the concepts called microservices. So what the microservices did is, now all these applications, or we can say functions, or we can say functionalities, okay, they were connected, they started communicating with each other with a standard language. Okay, or standard language I can say, or I can say with a standard interface. Okay, and we called it APIs. So with the advent of APIs, one simple example I'm saying, okay, with the advent of APIs, now what happened is, now let's say location guy is developing it, okay, and he knows like this will be the API structure which he will provide to orders. Now what orders did he know? He orders already has the API structure, right? So what he will do, he will use this API structure to develop his orders. Similarly, accounts will use it. Similarly, payments will use it. And so there is no dependency as such, because they already knew what they are going to get, what they are going to ingest, and what they have to provide. Okay, so that problem was solved, and they all started parallelly developing things. But the only other main problem which everyone was facing was the hardware, right? So when you're deploying the code, like there was dependency in the hardware also, like the CPU, like the order and location, both are running on the same CPU or the same instances, right? So the cloud, when the cloud came, that problem was also solved, because with the cloud, especially with the Kubernetes, or with the concept called containers, or we can say containerization, what happened is this hardware also got isolated into pods or containers. Okay, now what happened, each of these functions could be put into different containers, and they all acted differently. Like for example, the whatever resource the order is using, accounts is not using, okay, or payment is not using. They all have independent resources also. So the code also independent, resource also independent. So what developers thought is, okay, why can't then why should we stick to same language and all, right? So we can choose the different technologies which our team is expert in, right? So let's choose different technologies. So what happened, different technologies, different microservices started adapting. Like for example, like order team thought, okay, Java is good. Accounts team thought, no, Java, we will go with the Go. So similarly, every team had their own expertise, and they had their own viewpoints, own architects, they had their own reasoning behind why they want to go ahead with it. And similar, and this way, what happened, the systems became really complex. So that's why what happened is, now due to these complexities, indirectly, or we can say inherently, it led to different issues, and these different issues led to mainly the chaos engineering what we are seeing now. Okay, so as I said, now to put it in a blanket, now what are distributed systems? So this is the reason why the development became faster, right? The hardware and the code became very much independent from each other, and everyone had a courtesy of developing things independently with the microservices. But the problem was everyone became independent, but the testing became complex, because everyone had their own set of technologies, set of architecture, right? And this led to issues, and that led to the rise of chaos engineering, mainly the use of these distributed systems. Now again, to add to the complexity, there were hybrid systems also. Like for example, you had an application which few were on-prem, few were cloud, and they are interacting with each other, and such problems, like such complexity also increased. Okay, so that led to obviously the rise of chaos engineering. Now obviously cloud architecture, microservices, as we saw, and what people started to realize is outages are expensive. What do you think, like are outages expensive, or is it okay, manageable? Like let's say a company like Amazon is shutting down for, let's say, 1 minute or 2 minutes. What do you think will the loss be? Will it be millions of dollars, or like very negligible?
It's huge.
Yeah, it will be in millions of dollars. Okay, and this we are seeing, like you would have read in the newspapers also, the big giants, right? Like Amazon or Google, they also have outages, and it happens. Okay, and these outages are very expensive. Like it's in millions of dollars, and they don't need to spend that much for a chaos engineering team. That's a ROI which we are speaking about. Okay, so outages are expensive, and that's the reason again why chaos engineering came into mainstream, and it's like a vaccine. So my question to all of you is, what's the difference between a vaccine and a medicine? Like when I say a medicine and a vaccine, what is the understanding, like what's the difference you think both have?
So the vaccine is to like proactive to prevent any disease, and medicine is after something has happened.
Correct, exactly. So see, vaccine is more about a precautionary measure, right? Like before something happens, or before a virus hits me, I'm ready for that virus. Okay, and medicine is more about after the virus hits me, I want to cure that. Okay, so it's a cure. So this way, chaos engineering falls into the domain of vaccine. Okay, because here what we are doing is a precautionary measure for all the problems which might come. Right. So, for example, now let's say I am developing a vaccine, a coronavirus vaccine. So you would have seen like different vaccines are there in the market, and these vaccines, how they work is they actually inject a very less powerful, or we can say less strong virus into our system, into our body, right? So what our white blood cells will do, they will study on that virus, and it will create the antibodies required. Now that's how the vaccines work. So there are real virus inside the vaccine. Okay, but it's not very potent. Like it's little strong compared to the real virus. Now same thing happens in chaos engineering also, right? What we do is we inject the failures, not massive like the real failure, but in a small sense, very much close to the real failure, but in a weaker way. And we try to uncover the issues in our system so that if it happens later in real production, my system should be able to handle that. Okay, so I'm specifically using the word handle that, not withstand that, because that's where really the major difference comes from chaos engineering and other testing, like the failover testing and all, right? So we will discuss those things, like how you differentiate between failover and all those testing with chaos. Okay, so that you don't confuse with those, right? So that's why chaos engineering is more sort of like a vaccine. It's a precautionary measure for any problem. Okay. Yeah. So the history of chaos and all. Yeah. So if any questions, we can take the questions, or else we can continue tomorrow. Yeah. Okay then. If no more questions, let's stop it here for today, and let's continue tomorrow. Thank you all for joining the session. Meet you tomorrow. Have a good day.
Thank you.
Thank you, Vishnu.